Today's lesson on Unit 8 is all about the quadratic formula, which should be a review from Algebra 1. Before we begin though, let's do a quick review about what it means to find the solutions to a quadratic equation, or otherwise known as the x-intercepts or the zeros. Okay, so when we are finding the solutions or the x-intercepts or the zeros, and it's a quadratic, so remember a quadratic is in the shape of a parabola. It is the two or one spot where the parabola will cross the x-axis. Now those numbers, usually in the past, we've seen them be nice numbers. And what I mean by nice numbers, I mean rational. They are either integers or nice fractions like 1/2 or 2/3. But they don't always have to be rational numbers. Where this parabola crosses the x-axis could be an ugly number, aka an irrational number that goes on forever. There's no pattern, and the decimal doesn't end. So in that case, normally in the past we have factored. Use factoring to find the zeros, and our factoring types, if you recall, were GCF, 1AM, or split the middle. And then once you do split the middle, you'd have to do factor by grouping. Well, if where the roots occur or the zeros is not a pretty number, you're not going to be able to use factoring to do that. So if the roots or the zeros or the solution are irrational numbers, you're not going to be able to factor. You're going to want to use the quadratic formula. Now, the quadratic formula also still works if the roots are rational and nice numbers. But you don't ever really have to use factoring. You could always use the quadratic formula. It works always. But it's a little tricky and it's kind of gross looking. So if you know factoring, it's a little easier. But if you forget factoring, the quadratic formula will always work. The problem is factoring won't. If it's an irrational number, factoring is not going to work. You're going to have to use the quadratic formula. So here is the quadratic formula. The quadratic formula will give you your two x-intercepts, because you'll notice it starts off with x equals. So you're finding the x values of where that parabola crosses the x-axis. Now you need to know where A, B, and C are. They are the numbers. First of all, it has to be equal to 0, so you might have to move, if something's on the one side, you might have to move everything over to the same side to get it equal to 0 first. And then the letters A, B, and C are simply, they stand for numbers that are in front of your x squared, your x, and then your number that's all alone without your x. And they go in order. So as long as your quadratic is written in descending order by exponents, like x squared first, then x, then no x, or x to the 0, then A, B, and C go right in order, and they are the numbers in front. If you are missing one of these variables, or this number that doesn't have a variable, then it's 0. So for example, if you just had ax squared plus c, then b would be 0 in this case, so you would plug in 0 for b. All right, so let's do an example, and remember, if there is no number in front of a variable, there's an imaginary 1. So I'm going to start off by looking at this first quadratic, and I'm going to first notice that it is equal to 0, so I can go ahead and start with either my factoring, if I can factor it, or my quadratic formula. Now here's how I can tell this isn't going to factor nicely. If I tried to use 1am, okay, because there's a 1 in front, so we find what adds and multiplies. The only way to multiply to positive 1 is 1 times 1 or negative 1 times negative 1. Well, I have to find a pair that adds to negative 6. These do not add to negative 6. Therefore, I cannot use factoring. This is how I know I must use the quadratic formula. So I'm going to start by identifying who A is, who B is, and who C is. I like to stay organized and show my work. So A is 1, B is -6, and C is 1. Now I'm just going to plug those numbers into the quadratic formula. Notice, normally we do get 2 roots. If you look up at that picture I drew, there were 2 spots that it crossed the x-axis. And you're probably wondering, well, where are my 2 x's going to come from? Well, you'll notice in the quadratic formula there's this plus and minus. So first you're going to do the quadratic formula with the plus, then you're going to go through and do it again with the minus. So that's where you get your 2 answers from. So we're going to plug in -b. Well, if I plug in a -6, that turns into a +6. Plus or minus the square root of 6 squared minus 4 times 1 times 1 all over 2 times 1. And now I'm just going to do some algebra either on your calculator or in your head and clean this up a little bit. So this is 6 plus or minus the square root of, that's 36. 4 times 1 times 1 is 4, so 36 minus 4 is 32, all over 2 times 1, which is 2. Now from here, this is where you're going to use your calculator. And first you're going to do 6 plus the square root of 32, and then divide by 2. Make sure, to make sure you don't get it wrong, I would type in the top first, so 6 plus the square root of 32, enter, then hit divided by 2. One of your answers is 5.8, and then the other answer, so then you would do 6 minus the square root of 32 divided by 2, you get 0.17. So those are your 2 answers, and that's it. So we'll just do one more example, and then I'm going to move on to the next lesson because I think you can handle that last one on your own. You can try to do 1 a.m. for this again, but it's not going to work. And notice, look at my answers. If I go back to the first example, they were not pretty. I mean, this does not cross. And by the way, this did keep going. I rounded though. So that's how you'll definitely know that that would not have factored nicely. Okay, so over here, A is 1, B is -10, and C is 20. So I'm going to plug these numbers into my quadratic formula. So I get -10, which is +10, plus or minus the square root of B. Oh, by the way, this actually should have been -6, but it won't affect our answer because when you square it, it would have been +36 anyway. Same thing here. This would be -10 squared minus 4 times 1 times 20 all over 2 times 1. If when you're doing this, you get a negative underneath the radical, that can't happen. So if that does happen, you need to check the graph. So I would type this into your calculator and graph it and see if it even has roots. There are situations where a parabola might not have roots. It could be above the x-axis or below and never cross. So if that happens, it doesn't necessarily mean you're wrong. It just means it might not have an answer. So if you get a negative under the square root, make sure you graph it and check to see if something funny happened. Or maybe you just plugged them in wrong. Okay, so this becomes 10 plus or minus. That's 100. Right here, -10 squared is 100. 4 times 1 is 4. 4 times 20 is 80. So 100 minus 80 is 20. All over 2. So now I'm going to type this in my calculator the 2 ways. You have to do 10 plus and then 10 minus. So 10 plus the square root of 20 and then divide that by 2. It turns out to be about, and it's not a pretty number, so I know it wouldn't have factored, 7.24 rounded. It will tell you what to round to in the future. I didn't tell you in the notes. Then do 10 minus the square root of 20, hit enter, and then divided by 2. It's about 2.76. And it does keep going, but that's rounded. So those are your 2 intercepts. Don't forget, your calculator will find the intercepts for you if you graph it and then go to menu, analyze graph, and then look for zeros or roots. I can't remember what word they use on the calculator. Okay, so the last lesson is just more of the same. It's more just graphing or using the quadratic formula. except we have inequalities and systems. So in the first one, you are trying to find when is this ugly, it's a quadratic, they use t instead of x, but there's a squared, so I know it's a quadratic. When is this greater than or equal to 5? Well, in order to solve with a quadratic, the first thing you always need to do is get it equal to 0. So I'm going to subtract the 5 over to the other side, and I'm going to subtract it with the common term of negative 394. So I get 0 is less than or equal to negative 1 over 250 t squared. If you don't like t, you can call it x if you want. Plus 2.8t minus 399. Now, I am not going to sit here and try to see if this would factor. That would be gross. So what I'm going to do is use the quadratic formula. So I'm going to identify my A, my B, and my C. It's going to be ugly, but that's what you have a calculator for. So A is negative 1 over 250, B is 2.8, and C is negative 399. Make sure you're careful that you keep the sign that's in front of each number. Okay, so plugging that in, we get x equals negative b, so it'd be negative 2.8 plus or minus the square root of 2.8 squared minus 4 times negative 1 over 250 times negative 399, gross, but again, you have a calculator, all over 2 times a, which is negative 1 over 250. What I would do if I were you, in the last lesson I was doing this part in my head because they weren't bad numbers, but I would clean up the radical first, type just this in and see what it is. It turns out to be, so that's negative 2.8 plus or minus the square root of 1.456 all over, and then multiply those two together, it's negative 0.008. I mean, you could type the whole thing in at once if you want. Just be careful, because if you accidentally type it in wrong, you're going to get the wrong answer when really you knew what you were doing. So now you're going to go through and type this in twice, except you're going to first do it with a plus the radical and then minus the radical. You get two answers. You should get two answers of 199.169, and the other place it crosses the x-axis is at 500.831. Again, check on your calculator to make sure that's really where the roots are. And the last one, systems of equations. Whenever you are asked to solve a system, that means you're going to have more than one equation, and you want to find where they cross or intersect. So you could graph it and find where they intersect, or to do this algebraically, you're going to use substitution. So I know that y equals this, 6x minus 3. So I'm going to plug that in for y into the other one. So I'm going to replace this y with what this y equals. So I get 6x minus 3 equals 4x squared minus 6x plus 2. Whenever I see an x squared or a t squared or whatever squared, I should be thinking to myself, I got to get it equal to 0 and factor. And if I can't factor, I have to use the quadratic formula. Or just always use the quadratic formula. So we're going to subtract the 6x and add the 3 over to the other side. Make sure you do common terms. So now I get 0 equals 4x squared minus 12x plus 5. Now, I will tell you right now, this one does factor nicely. You can do split the middle. So you would multiply 4 times 5, that's 20. Find the factors of 20 that give you negative 12. It does work out nice, but I will show you that you can still do the quadratic formula even if it does work out nice. You'll notice something nice actually happens in the quadratic formula if it is factorable. So A is 4, B is negative 12, and C is 5. So it's negative B, so it's a negative negative 12, so that's 12. I should always start with x equals. Plus or minus the square root of negative 12 squared minus 4 times 5, all over 2 times A, which is 4. So underneath the square root, you're going to end up getting 64. And you should be thinking, wait a minute, that's a perfect square. That's going to be a nice number. The square root of 64 is 8. So that is how I knew that this actually would have factored using either 1AM or GCF or split the middle, because the square root turned out to be nice. So it's not going to be an irrational number. It's actually going to cross at a pretty nice number. So let's just go through and finish the quadratic formula. First, you're going to do 12 plus 8, which is 20, divided by 8, which isn't a nice integer, but it's not that bad of a number. So 20 divided by 8, if you take out a 4 from both of those, that's a 5 over 2. So it crosses at 5 halves. The next one you're going to do is 12 minus 8, which is 4, over 8, which is 1 half. So your two answers are 5 halves and 1 half. And that is it for working with the quadratic formula. And so we're done really for this unit. So be prepared for a review and a test soon.